Okay, here we go. Mechanical drives and bearings, Unit 5. This will be on clutches. So why do we need clutches? Basically, what you got is you got something that's rotating, connected to something you don't want to rotate all the time. Think of a car, okay? You come up to a stop sign. You don't want your back tires rotating through the intersection, right? So you got to have a clutch in there to stop, even if it's automatic and you're not aware of it. So you engage or disengage a driven rotating element. If you need a constant torque, if you don't know what torque is, ask me. We got to have constant torque applications. The clutch is one way to do it. If you want to limit your torque loads, you don't want to break anything with too much torque, this is the way to do it. You can set up these things so you can have automatic disconnection, automatic clutch. Drag racing and NASCAR, you need quick starts and stops. You couldn't do that with an automatic transmission, so they have a clutch. And also, if you need to be gradual, just the opposite, or for non-reversing or overrunning functions, we'll talk about what those are. Clutches will let you do it for gradual starts and stops. Two ways to classify a clutch. One is how they're engaged or speed controlled, or otherwise they have a physical characteristic, something unique being used with them. We'll talk about those. This is a mechanical clutch. This is what's underneath a car in a stick shift. So you push the clutch pedal, right, and it pushes a lever. The lever then pushes on a clutch fork. That clutch fork basically picks a plate off from the engine. So your back tires are no longer directly connected to the engine, which is good, right? Or your front tires, if you've got a front wheel drive. But this is how it works, right? Just push on that, and basically it just pushes that plate off the motor so you can stop or get started however you want to do it, whatever you have to do. This is an electric clutch. Think of a riding mower, right? You got the engine going, but the blades aren't turning. So what you do if you want the blades to start turning, you just pull the PTO. Well, what that is, power takeoff is what that stands for. What it does, it supplies electricity to an electric clutch. Electric clutch gives a little force and connects the blades to the motor, and the blades start turning. That's all there is to it. Very simple, right? Very expensive too if you ever break one. It's a hydraulic clutch. Same idea as a mechanical. Basically, the force though isn't coming from linkage. It's coming from fluid power and liquid fluid power. And so what happens is you get this thing out of force, and that force picks the plate off from the engine. And not all fluid power is liquid. This is an example of a pneumatic. Same idea, it's just as air instead of liquid. This is a automatic clutch. Just going to say, if you need to fix one of these, hire somebody to do it. These are very complicated. Unless you know what you're doing exactly, you can get in a lot of trouble with these. But it's very complicated, but they work great. You don't have to think, there's no operator interface. It's all automatic. There are several methods for making a clutch work. First one we're going to talk about is positive. There's a square jaw. Basically, it's just got four beveled pieces. And when you want it to engage, in other words, get the driver to drive the driven, three drives in there. But what you do then is you push those ridges into the other ridges, and they lock up, and you're on your way. You can probably figure out that's kind of tough to match up those slots. Spiral jaw is a little bit more forgiving. They got one flat edge, and then they got a beveled edge, so it can kind of just slide in there. Then finally you got the multiple tooth. This is just basically you got ridges, a lot of ridges, and you put them together, and they made up, and you're locked, and you're on your way. This is positive. Positive in the sense that it's connected, mechanically connected to the driven and the driver. So you can imagine if you got a positive, that's not so good, right? If the motor's turning at full speed or something. So another method to do is just friction. Basically, get a couple of smooth plates and put them together. The friction stops the driven unit from turning, and you get to change gears or whatever. But this is the friction method. This is for when the prime mover, in other words, the motor, is in full motion. We'll talk a bit about that later on. This is a radial friction clutch. It's like your brakes on your car, right? You push the brake, and it slows down the wheels from turning. Same thing with this. You push the clutch, and it pushes and it stops the driven unit from turning. You can do it either throw them out or you can have them squeeze in, expanding or contracting shoe. But it's basically just a big a brake shoe, except we call it a clutch. Okay, this is a single disc friction clutch. Single disc, just one disc, and it pushes up against the flywheel. And so that's why it's single. There's another method, and I'll get that to the next slide. Or you can stack up a bunch of these like pancakes, and then just squeeze the whole pile together. That's called a multi-plate clutch. All right, same idea, just more plates. Okay, this is a tooth friction disc clutch. What it does, it has two purposes. One, it acts as a clutch, but also with the gears on there, it also is part of the drive system. So it's like you get a 2-for-1 with this thing. Um, Same idea. It just also is connected to the drive. Two types of axial friction disc designs. One's a rigid, the other's a flexible. And this is a picture of the flexible. And the key thing on this is the springs. So when you slam that up against the spinning part, those springs kind of absorb some of the shocks, gives it a little bit of flex. Rigid doesn't have those springs. It just takes the full hit. This is a torque limiting clutch. There are different designs for this one. There's probably a gazillion ways to design this thing to make it happen. And what you do is this thing, when it hits too much torque, again, if you don't know what torque is, ask me. I'll be glad to explain it. You get too much torque, this thing kicks in and reduces the torque to where it has to be, prevents overload condition. Torque limiting clutches. Two types of surfaces for friction, non-metallic or metallic. Non-metallic, I think the book says they're still using asbestos. No, they're not. Non-metallic is anything that doesn't have a metal in it. There's some actually very good composite. Kevlar comes to mind. But if it's not metal, it's non-metallic. If it's got some kind of metal in it, it's a metallic. It's just that simple. Both have their advantages and disadvantages. If you ever have to replace one, just go to the manufacturer spec and it'll tell you which one to use. The wrap spring, if you ever taken a spring and try to unwind it, the diameter gets bigger. If you try to tighten it or turn it the other way, the diameter gets smaller. So what they do is they put the spring on a couple shafts. And depending on which direction it's turning, it's either getting tighter or looser. And that allows for engaging in one direction and freewheeling in the other. That's the wrap spring. Magnetic clutches, these are non-friction, and what it does, it uses magnetic force instead of mechanical force. There is no mechanical connection. It's all straight electromagnetic. There's one type, electromagnetic activation on friction disk. If you think of the electric clutch earlier in this presentation, that's electromagnetic activation. And as soon as you pop that PTO button out, your blades are spinning. That's the advantage of electromagnetic activation. Now the eddy current clutch is kind of a neat concept. What it does, it puts a big coil in there. And what happens then is you energize this coil in one of the driven or the driving component. When you activate that, it magnetically couples to the other part, and so that coupling, it doesn't want to move from that. So what will happen then is it'll kind of bond together and spin together. That's eddy current clutch. Basically, just get a big magnet between the parts. They don't move and spin together. Centrifugal clutches. These things are basically, they rely on centrifugal forces. And what it'll do is it basically uses the mass of whatever's inside that clutch to engage the clutch. So what happens is until you get up to a certain speed, the clutch will slip until the load is picked up. All right. Lugging and stalling is prevented because you start lugging or stalling, what will happen is the mass will just fall back to the center. So it's not going to stay locked, right? You don't need any special motors. It's just straight old-fashioned physics. And like any fluid, it's a good shock absorber and dampens out vibrations. If you got a lot of prime movers, in other words, another bunch of motors hooked together, it'll kind of equalize all those out, right? Because it all depends on how the centrifugal forces are in there. And if you fluid clutches, think automatic transmission here. If you stall out the driven load, so if you stop the back tires of a rear-wheel drive car, it's automatic, the motor will still be putting out the torque. It gets transmitted, just doesn't get transmitted to the driven unit. Some different types of centrifugal clutches. There's a shoe clutch, and basically what happens is it's as this thing picks up speed, a shoe gets pushed up against a drum, which causes a clutch to engage. The fluid clutch, again, this is automatic transmission in the old days. So what it does, it just kind of pushes water or any kind of fluid to the driven unit based on the RPMs. And the dry charge fluid, what that is basically they just get a bunch of little small, usually beads, throw it in a clutch, and it acts like a fluid, even though it's actually dry, it's metal, it still flows. It's kind of like that sand going through your fingers. That's what it's kind of look like. It's hard to hold a bunch of sand, dry sand. That's what this is. If you're going to install a clutch, don't try it the first time by yourself. Have somebody that knows what they're doing there with you. Also, YouTube's got a video for any type of clutch you're trying to install. My personal horror story, I had a 3/4 ton truck, and I had paid somebody to replace the clutch. I didn't have the tools. Well, what he did is he didn't get the clearance between the pressure plate and the clutch. So what happened then was that thing ever was spinning, it'd get hot because it was always rubbing. Well, as it got hot, it got brittle. So I'm about 500-600 miles away from home, and all of a sudden this brittle clutch just shatters, just breaks like a plate dropping on the floor. So I didn't have a clutch going up I-35. So and plus after it broke like that, all of a sudden all the pieces of that clutch got into the gears and everything, basically ruined the whole transmission because it wasn't installed right. Never let your friend replace your clutch without you there to watch him either. But don't try this alone the first time. Get somebody that's experienced to help you with it. And that's all I got to say about clutch installation. I've done several of them, but they're not that bad after you get used to it. But there's some little tricks you got to be careful of. Okay, last slide. If you're in maintenance, you got to check your clutch. Use the book and use that as a checklist. These are all visual checks, right? And you can tell when something's not right. You see wear, uneven wear. It's very easy to spot. And again, alignment. That'll be our last chapter. It'll be our last lab. This is very important. If you have any questions about this presentation, just ask, okay?